Recently, I made the decision to invest in some proper lighting equipment. This included a Nanlite FS300 and Godox softbox, and some other things. Compared to my old setup, the improvements are incredible. I can now use Bowen's compatible softboxes and light modifiers, and the light output is just amazing. My previous lighting setup didn't weigh much, but it was annoying to move around. This new setup, however, is much heavier, and with the 95cm softbox, it's pretty irritating to lift up and adjust for different shots. While browsing filming equipment online, I came across a product which looked like it might be able to solve all of my problems. A set of caster wheels which you attach to your light stand legs that give it the ability to roll around. At this current stage though, I wasn't willing to spend more money on something that I wasn't sure would be suitable, so I decided to try and make my own. I already had the wheels from a previous project which I got at the dollar store, so the only thing I need to do is take some measurements and do some 3D printing. Since my new light stand hasn't arrived, I'm going to be using the old one that came with my previous lighting setup. The stand uses a rod clamping mechanism, so I'll take inspiration from this as I think it could work quite well. The stand's legs are 16mm in diameter, so I will design the parts around this so that they can be slid on and then tightened. Initially, I tried using a protractor to get the necessary angles required to design the part in CAD, but in the end that didn't work out. I first began by modeling one of the stand's legs for reference and rotated it at an angle. Then I started designing the clamp around it. If the cutouts for the nuts look disproportional, that's because they are. I made many mistakes in this first model, but thanks to them, I knew what needed to be improved upon. That's part of the joy of iterative design. Printing the part out on my Ender 3, which suffered a filament change partway through, we can see the things that need to be improved upon. This includes the cutouts for the nuts, but also the wall thickness, which is way too thin and flimsy. Testing the clamp by tightening it onto the leg of the stand, we can see that it does prevent some slippage, but needs to be much tighter if we're going to be using it. I also measured the M3 nuts to get the correct dimensions for use in CAD. Hopping straight back into Fusion 360, I began by increasing the wall width of the part and redesigning the cutouts for the nuts so that they would fit better. Printing the part out again on my Ender 3, all went well and no filament change occurred this time. A quick glance at the part shows no observable flaws, but when we try to insert the nuts, they don't fit again, so I'll head back into Fusion 360 and increase the dimensions once more. Hopefully they're going to be fixed this time. I realized that the mistake I made was inputting the width value as the radius value, which explains why the cutout was incorrectly sized. I'll quickly fix this, slice the part, and print it out for testing. Testing the tolerance of the part on the leg reveals that everything is good, so it's now time to design the adapter plate to attach the leg to the wheel. I'll do this by tracing the outline of the wheel onto a piece of paper, then measuring the dimensions with my calipers. These dimensions were 36mm and 50mm. Returning to Fusion 360 again, I began by creating a sketch with the acquired dimensions. The plan was to create a rectangle with correct values and then place the screw holes on the corners, then add a border around them. I then oriented the part and tried using a loft tool to connect it, which didn't work, so I just extruded certain areas of the part instead until everything was connected. I also added a little brace at the back for support. When it came to testing out the prototype, I suddenly realized that I had messed up, and that the part would not be able to be tightened as everything was connected. While testing the locations of the screw holes, we can see them line up, so at least those didn't need to be changed. Frustrated, I quickly thought of a way to make the part work. I decided to tear down my previous clamp idea, but keep the adapter plate, since that worked well and had been proven to. It would have been simpler to just remake the adapter plate separately in a new project, but I didn't feel like doing that. I decided to use friction to keep the adapter attached to the leg. That way it would be easy to remove with a bit of force, but it wouldn't come off on its own. I did this by extruding multiple rings with different inner diameters, gradually getting wider at the top or smaller closer to the bottom. A quick print and test fit proved successful, so it was now time to combine the designs together. Observing the new iteration, we can see several improvements, such as it being easier to print due to simplicity and requiring no additional hardware such as nuts and bolts. Inspection of the printed part revealed no failures, and even the inner rings printed all correctly, so it was now time to do a test fit. With the test fit being successful, I then moved on to finalizing the design. I did this by basically adding fillets to most of the object's corners. With the final design loaded up onto the printer's SD card, it was time to print out 3 copies. Here is a little showcase of each design showing how they were improved upon until we got to the final design. The first design was lacking a lot of the required dimensions such as the correct wall thickness and cutout size. In the V2, these areas were improved, but the cutouts still needed some tweaking to be perfect. The V3 solved all of these issues, which is why in the next iteration, all these features were combined along with the adapter plate to provide the first real prototype. Unfortunately, I didn't realize that this mechanism wouldn't work at the time, so I switched over to trying to use a friction method instead. This method proved to work well, so I incorporated it into the next design, and in the final design, I used the fillet feature to tidy things up, giving us the final result. Installing the adapters onto the stand, we are shown that everything still fits of course, and the wheels can be attached without any problems. Installing the rest of the hardware onto the other parts only took a minute or two, and I was left with 3 completed wheels. With everything installed, let's test the setup. It moves, but it feels flimsy and the adapters rotate slightly. Still, this is a win for me, so let's complete the setup with the light and softbox. Everything seemed to survive with the added weight, so that's an extra win in my book. Rolling the stand around is unfortunately not as easy as I hoped it would be. I have some ideas on how I can fix this in part 2. However, that does bring us to the end of the video, so thank you so much for watching, and hopefully I'll see you again soon.